heuristic mechanism for auto-organized drone swarm control. For the abstract, in the literature, we can find applications based on drone swarms where each drone is coordinated independently by a person. It can be radio controlled or programmed, but there are some applications that require to monitor or perform tasks on extensions of very big areas, and a single drone won't be able to make it easily or in a required time. This is why a drone swarm it is used. It is a set of drones that will independently perform tasks on this big area. The mechanism we are proposing is a drone swarm based on restrictive tasks. This is all with precedence. This is that the drone will require to perform one task after another drone has already finished. As mentioned, a drone swarm is a set of drones, heterogeneous drones, that are going to be performing the tasks. Several functions are defined for this algorithm that needs to be developed. Areas to visit. The areas to visit are the areas that each drone of the set is going to be visiting and performing the task. Each area is a set of has a subset of areas which are defined by Cartesian coordinates that define a quadrant that the drone is going to be visiting. So the outcome of this function is a positive real number where an element of the area of the set A, or for the area, will be covered by an element of the drone swarm D. Drone data transfer. The drones need to exchange information between them in order to perform the tasks. So the drone set is defined by a set of drones that is an array that has this information for the predecessor. This is the drone that it's going to be before the other drone that is going to be doing the execution, and a set of drones that harbors the association. And this association means that after the drone has finished, which drone of the set is going to be the next one to execute the tasks. The outcome of this function is a positive real number, where the elements are specified for precedence and success. The objective function is where it is defined the area that, not the area, the time that takes a drone to visit an area, and it is defined by a cross product or vector between the area to be visited and a time. The outcome of the function is a positive real number where the objective function is a time in seconds that takes the drone to visit takes one drone to visit a certain area. Since we're going to talk now about the function for the cost of data transfer. Since we're not going to be since it is the possibility that we're not going to be having the same model for all the drones that are contained in the swarm. The swarm is going to be heterogeneous. It can be one type of drone or another. Each of them has a cost of data transfer. This data transfer is defined in time, and it has to be with the time that the drone takes to start transmitting the information, the time that takes for the data to be transmitted from one drone to another, and a transmission rate. This is how many bits per second is going to be transmitted between one row and another. The outcome of this function is a positive real number where the time in seconds of the cost of transfer data is defined. The next function is the estimated time of arrival. The estimated time of arrival it's regarding the time that the time that one drone takes to go to reach another area that it's going to be visiting. The estimated time of arrival is defined by the cost of data transmission that we already defined in a previous point, and also the time asset of time in seconds that takes from one drone to reach one area to another. Let's say we have an area of 10 meters, and the time is going to be taking from one drone go from meter 1 to meter 3. The outcome of the function is a positive real number where estimated time of arrival is in seconds, and it is the time that takes one element of the drone's arm to reach from the starting place to the next area to visit. Estimated time to exit is the next function. It is regarding once the drone has reached the next area to visit. This is for the time for that drone to execute its program tasks. This time is started to be counted from the time of estimated arrival plus the time of the drone takes to perform the program tasks. The outcome of the function is a positive real number where estimated time of exit in seconds takes to a drone to perform the program task and exit the current visited area. The function that connects everything, it is called makespan. The makespan is defined by the set of estimated time to exit of all the elements of the drone's arm. This is, we're going to have a set for each drone and each area that is going to be concatenated with the time of exit of all the areas that need to be visited. The outcome of this function is a positive real number where the estimated time of exit in the total time takes to all drones on the swarm to visit all the areas to perform all the tasks. This is the time that completes all the functions. If we have 100 drones and we have 200 areas to visit, this is the makespan is going to be the function of all the areas that are going to be visited by the drones, like previously was programmed and by the algorithm. This makespan function is the one. It's the one that is going to be targeted by the algorithm to reduce the time each time. Sorry, not the time. To reduce this number of the time that takes to perform all the tasks in all the areas. So the makespan needs to be optimized for time efficiency each time the algorithm is run. For last is the algorithm that has 8 steps. The first step is to create a list of areas to visit. Second step is determine the order and priority of the drones, considering the precedence of the tasks. This priority is which drone is going to be visiting which area first. Then with this we are going to create a list of drones ordered by priority, and then we are going to perform the visitings of the areas by the drones during a cycle loop until all the areas are visited. Thank you very much. My name is Juan Munoz. I'm a graduate student of the Universidad Autónoma de Ciudad Juárez. This is for my master's thesis project that I'm doing. Then it is heuristic mechanism for auto-organized drone swarm control.